Welcome to Inside AI, a podcast from the EPFL AI Center. I'm your host, Marcel Salate, professor and co-director of the EPFL AI Center. Each episode brings you fascinating discussions with brilliant minds from EPFL and across the global AI community. From groundbreaking algorithms to ethical considerations, from technical innovations to real-world applications, we explore the technology that's transforming our world. Whether you're an AI researcher, industry professional, or simply curious about the technology that's shaping our future, join us as we venture inside AI. Today, I'm really happy to speak with Eamonn Maguire. Eamonn leads the machine learning team at Proton in Geneva. It's a team that keeps quietly one of the world's most trusted privacy-focused ecosystems safe from abuse, spam, and all the weird things the internet throws at us. Eamonn has a fascinating background, a PhD from Oxford, time at CERN, and now several years at Proton, where he's been shaping how the company builds AI in a way that actually respects users' privacy. If you've ever wondered how to combine cutting-edge machine learning with a genuine privacy-first philosophy, Eamonn is one of the few people who actually does this in practice every day. And what I really appreciate about this work is that it's not just theoretical. It's real systems used by hundreds of millions, email, storage, VPN, and now AI chatbots, and making sure they remain trustworthy. Now, the Proton founder, Andy Yen, will also be a speaker at the upcoming AMLD Intelligence Summit in February 2026. And tickets are on sale now. There's also early bird pricing depending on when you're listening to this episode. And we just have fantastic tracks and keynotes and workshops and fish bowls and unconference style roundtables and much, much more. We designed the event from the ground up, renamed it slightly to have it reflect this human and machine intelligence convergence, hence the AMLD Intelligence Summit. And like every year, we have fantastic speakers like Andy Yen, and I'm very much looking forward to seeing you there as well. For more info, go to 2026, that's 2026.appliedmldays.org. And now to the conversation with Eamonn Maguire. Good. Eamonn, thanks so much for being here.
Thanks for inviting me.
Good. So you're at the Proton, and I think Proton is one of the most fascinating tech companies for different reasons, and we can go into the details later. But yeah, could you just give a bit of a summary of basically who you are, what you do at Proton, and perhaps then also speak a bit about what Proton's overall mission is?
Sure. So at present, I'm the Director of Engineering for AI and ML inside Proton. So primarily at the start, whenever I joined Proton, which is 5.5 years ago, I was working more on anti-abuse systems, so protecting Proton against bad actors and protecting its reputation and so on. So we're building lots of systems for bulk account detection, spam and phishing protection, and so on. And then after some years, we became quite good at that. And I was always kind of interested in more the product focus, doing AI, but in a privacy-focused way, rather than AI just in front-loading into any application and seeing how you go. So this was kind of a possibility last year. So last year was our first foray into AI, I would say, inside the product with Proton Scribe, which is basically an AI assistant directly within the mail application. The big USP of this was that we were doing things locally as well as server-side. Everything was private, as in we don't log anything, of course, on the server side. But also, if people really didn't want to trust Proton with any data, they could also optionally use the local mode as well. So that was an foray, I would say. The initial reaction was overall kind of positive, probably 60-40. But after some amount of time, people started to see that these types of products, they generally required some AI integration to keep up with the rest of the other products. Like Gmail was starting to look at it, Microsoft are looking at it. So people, when they choose privacy, they don't need to necessarily choose a worse product in terms of what they're getting for productivity. So after maybe 3 months, 2 months, I think, we released the new version of Scribe, and at that point, people sort of changed their reaction, and instead of complaining about Proton going into AI, it was more, why is AI this not included in my ultimate bundle, right? So that was an interesting shift, which sort of gave us some impetus into saying, well, I think we need to go this line and we need to go a bit further. Then, of course, we went into Proton Lumo, and that was a full-bodied product, going with all the stuff that I've never really done before, I would say. Lots of learning experience in that. So overall, my experience of Proton has been varied, going from anti-abuse systems. Then I built the CAPTCHA system, for example, for like the Proton CAPTCHA system is something that I built with another person in my team a couple of years ago, and then into like these types of features and then products. But overall, Proton's goal is to be, you're sort of, whenever you think about privacy and you want to go for mail or for storage, for Drive, for example, or for VPN, that you think of us as being your solution to that. And AI is the natural evolution in that space. The way people are consuming information now is not overwhelmingly AI, but it's really growing fast.
Yeah. And can you give us a sense of Proton, the companies? I mean, you've been around, if I'm not mistaken, since 2014. So you had a 10th year recently. Well, 2 years ago. What's the scale these days of the operations? Because I think a lot of people, that are not close to the Proton universe don't actually realize that. So is there something you can say in terms of size of how many people you are, how many customers you serve, and so on? That's publicly,
Yeah, we say in the public website that we've got over 100 million subscribers. It's much more than that, because that number was from 2 years ago, I think. I don't think I can say how many we have exactly. I'll wait for them to update the website, but you can probably guess if we're growing, basically these days about 100% year on year. So it's really quite fast. As a company, we're 667 people, because I checked our internal system the other day, just yesterday, in fact, on this. Actually, it was 666, and we thought it was funny because we had the Halloween party yesterday, and that was the reason why it was topical. But then including Andy at 667. Yeah, it started off as mail back in 2014. It was a Kickstarter campaign. Basically, after the Snowden revelations, the story goes that Andy was sitting in the canteen at CERN. He was a PhD student there and doing particle physics. And he decided after the Snowden revelations, also being Taiwanese, he also has a strong understanding in the value of privacy and also the right to exercise your democratic rights. And they decided basically to start looking at building private email. And that's where Proton Mail started. And they had, I think, 500,000 or something more than that in Kickstarter funds that basically started the company. And it's grown organically since then. We don't have any real VC funding or anything like that. It's just the money that we're getting from subscriptions and from our customers is driving the product to offer it for free also. The VPN product, for example, is really available to all around the world. As soon as something happens or some restriction comes in place, people turn to Proton VPN to help them get information. And we provide that free. People do pay for Proton VPN. That's how we survive as a business. But we also offer a free VPN that doesn't track, it doesn't sell your data. And that's a rare occurrence within this type of market. And then since Mail, they added VPN, they added Calendar, they added Drive, Proton Pass for your password manager, Wallet for Bitcoin, Authenticator, Lumo, and there's probably something else I'm forgetting too. But and then we've got Meet also, which we released in early mode. But basically, our strategy or our goal is to become an alternative to Google, a full alternative to the Google suite or Microsoft suite. It's going to take a little bit more to get there, I think. There's a lot of stuff that they've built up over the years, and they have a lot more people than us. So as I said, we're 667. They're in the, I think Google's like 140,000 people or something like that. Facebook's like 80,000 people. So it's we move fast. We move as fast as we can. but we're also not as big. But it means we can also move faster with when things change. We're obviously more nimble because we're a smaller company. We have small teams, hyper focus, and so on.
Yeah. Plus, so that means you also still have all the upside in terms of growth. But I mean, already those numbers are like super impressive. And where? So how do we have to imagine you're a fairly distributed company, or you how are you set up there? I mean, there's some in Geneva, but they're presumably in many different places as well. How do you function there on that side?
Yeah, so we have I think it's around 100 people in Geneva. I think around 40, between 40 and 50 in Zurich. I might be wrong with the number, but it's around that. Then we have offices in London, Paris, Barcelona, Prague, Taipei. We have quite a decent sized office. Actually, most of the people I work with are in Taipei. And for the first 2 years, during the COVID pandemic, that's when I joined Proton. It was in 2020. I don't think I actually met any of my team in person for 2 years. So it was kind of interesting. So we believe in like the office first type of approach, having the interaction with people and the serendipity and so on that you get inside the corridors. And I think that can be valuable. I think a lot of people became tired after COVID of staying at home all the time. I like the hybrid approach, and we have some days at home and some days in the office, and the rest. But we're primarily communicating with everyone online and different time zones. That's also effective for coverage, especially in my role in sort of anti-abuse and account security. Having 24-hour coverage is quite helpful. Also, when you work in product delivery, you also have to be 24/7 active. So you need people split around. So if something happens, you don't have to wake up at 3 o'clock in the morning to go and fix it. You have someone in Taipei, for example, to help you do that. And then we've got a lot of our customer support operations are in North Macedonia, and we have around 130, 140 people there.
Okay, interesting. And so we'll get into the weeds of the AI offers, but before, just one more thing on a more personal side. So you yourself, as you mentioned, you joined about 5 years ago. You have a computer science background. What's your path from that background to where you are today? Did you also go through CERN, or no? That was
Yeah,
oh, you did. Okay.
yeah. So I did my undergrad in computer science. I went to CERN immediately after that, in fact, for a summer studentship. After reading Angels and Demons, I thought CERN looked an interesting place, so I decided to go to CERN. Yeah, I'd like to meet Dan Brown in person because I think he had a lot to do with the path I had in the end. I never thought about myself working in academia before that point, but going to CERN and working there and the stimulation and stuff and the people that you work with are super smart and engaging. After that time, I decided that's where I wanted to go back to, and I sort of focused on that. But I returned back from CERN after the summer studentship and did my master's in bioinformatics. And after that, I worked at the European Molecular Biology Laboratory in Hingston and Cambridge for almost 2 years. And then at that point, I was at a fork to decide to do the PhD or not. And it was either going to staying in Cambridge and doing it in molecular biology or computational biology. I was very interested at that point in simulation, basically simulation for drug discovery. That was my passion at the time and my proposal for the PhD topic. But instead, I went to Oxford and did it in computer science, focused on more in the data visualization aspect, which is then what sort of got me into working more in machine learning, the fundamentals, I would say at that time, because we were building visual analytics systems and so on for modeling and for biological workflow simulations and all this type of stuff, which is, for me, it was my primary entry into doing more machine learning, but always with the focus on data visualization. And then I went to CERN after that for my postdoc because it was always my intention to go back to CERN, and I got the opportunity to go back. And I worked a lot on, it was more open science type principles. So I did a lot of stuff on semantic web during my bioinformatics times. So I was sort of working on ontologies and enabling those for biologists. I was doing a lot of the similar stuff in physics. but basically linking the theoretical with the experimental worlds with quite a few projects, the open data portal and HEP data and all this type of stuff, which I was working on. And well, CERN is only giving you the problem sometimes with academia is the short-term contracts or not knowing exactly where you're going to be in 3 years or even less than that. And I decided at that point that we wanted to stay. My wife and I wanted to stay in Geneva. She was working at EPFL, in fact, on the Human Brain project. So we decided to stay, and so I ended up moving and getting a job at Pictet as a private bank in Geneva, working as a data scientist. That was pretty cool, I would say. It was, I think, by the end I was ready to leave, but I learned a lot working in finance. I think, when you work in academia, sometimes it's not always, you don't always get the immediate feedback that something is working or not working. With finance, my goal was to go into something where you could see, you get more money or you get less money, but you have feedback there. And I got some of that in some places, but overall it was more of a learning path, I would say. I learned a lot by working there, focusing 100% almost on building models and building systems that were integrating those models. But I was very much focused on building products that integrated ML and AI, not just building, analysis pipelines and then having nothing at the end of it. So that was already something that I was interested in doing. And I left Pictet and went to work at Facebook, which is basically in the middle between me going to Proton. So at Facebook, I was leading the team for machine learning and data science approaches for internal, external threat detection. So basically everyone trying to get into Facebook in terms of attackers from outside, but also people trying to exfiltrate data within Facebook on internal profiles. And after COVID, it became more complicated. So luckily Proton had a job open for this ML engineering position in anti-abuse, and it was kind of perfect because that's what I was doing at Facebook. I also had worked in it during my PhD on insider threat quite a bit, which is why I got the job at Facebook. And so I think it seemed sometimes when people look at my path, they think it's quite random, but in the end, there's always the fundamental, the baseline is always the computer science aspect. So no matter which field I was working in, it was always about bringing, the computer science was the constant, and then you learn things in working in biology or working in physics or working in finance or in security. You learn to apply things, for example, and people always, I tell people this story about algorithms in biology and bioinformatics and how you can apply those in finance. And people never really understood what I was talking about because it seems such very far apart. So I think you're also very involved, right, in biotechnology. Yeah, and when people use Clustral, they're always doing sequence alignments and so on. And in one of my first things I did when I worked in finance was basically converting basically time series strings into symbolic approximations. And then with those symbolic approximations, basically letters instead of the numbers that you have on a graph, you start using Clustral then to start doing sequence alignments. So if instead of doing dynamic time warping, you basically just start using sequence alignment on these strings, and that would end up aligning all these different time series or basically stocks. You can have stocks and you can have credit markets and you can have whatever you want, FX rates, and then you can start aligning them with deletions and everything. And say for example, if you didn't really care about certain types of differences, you could just change the weights. So I like this fusion of different fields and trying to learn from one field to apply it to the next. And so far it's worked out. I think even in security, it's also worked out pretty well as well.
Yeah, oh, that's nice. And of course, you just gave a perfect pitch for a polytechnical education, right? Of the kind that we're trying to give our students at a place like EPFL, but certainly elsewhere as well. I mean, that's always the thing, right? People sometimes don't understand how that works and how more and more these approaches that we're teaching are just universally applicable. I mean, now you're doing this, but in another phase, you could be doing drug design, or you could try to to try to beat the stock market or whatever, right? It's fundamentally the same or similar approaches. Yeah, that's super fascinating.
I'm very much into that. I don't think I would classify myself as a polymath, but I would like to be one. I mean, I like and I think in this world where, there's a lot of uncertainty over what happens in job markets, for example, at the minute it's more overstated, I would say. But there is going to be a change, and there's always a change in the types of jobs that people do. And we've been in a time where maybe 30 odd years, 40 years of software engineering as being really something that was growing. And we're riding that curve somewhat. And there's going to be a shift. What matters is not necessarily what the job changes to be, but your ability to change with it, and to see that, not to be scared of something changing just because it's going to be something new. And I think that's when you've studied many different domains, one, you become more interesting, but two, that you've got different things to use whenever you're trying to solve a problem. So understanding how one domain solves a problem can help in solving another. And I remember, at Oxford, one of the cool things is that when you sit with people at lunchtime, you don't sit with other computer scientists necessarily. You're sitting with people who are doing humanities, or someone's doing some research on some virus strain you've never heard of before. And by sitting together and talking together about different things, you can end up helping as well. So I remember one person was studying the effect, or how electricity came into literature. That was her PhD thesis, was about this. And I said, wow, that's a really cool topic, something I never thought about, which is the thing which is, I think the more interesting thing is discovering all these things that other people are interested in. And she was struggling because she had to go through, all of these books in the library, trying to go through all the transcripts, trying to find the references. And I think at that point I introduced her to Google Books. And she's like, oh, wow, this is cool. So now you can start searching for different terms or keywords, and then finding which books were indexed by Google that could give her some lead into finding other things like references and so on. But even these little small sort of interactions can end up having an effect on people's research. And that one's an easy one, but there are many other ones too. I remember one of my really cool moments in my life was I'd been to the Antarctic twice, and the reason for that is because I have a friend in Oxford that I made at Oxford who's a penguinologist called Tom Hart, and he basically invented the term when he was interviewed one time by the BBC on his research, and he asked me to help him with some things, and I helped him, and as payment for this, I got to go to the Antarctic as a thank you. And yeah, in this case, it was just meeting someone at a pub. You talk to them for a bit, say, oh yeah, actually this is super interesting. What you're doing could help me in this. And then you have this sort of collaboration, which ends up bringing you to unexpected parts of the world and adventures. And I think people should just say yes to things and see where it goes.
Yeah, I fully agree. This is really interesting. I also consider myself to be a bit more of a generalist, which I think has many benefits, and you mentioned many of those. And as someone trained in evolutionary biology, I also know that when environments change quickly, it's better to be a generalist, right, as you say. But then the system, right, really proactively tries to turn you into a specialist. So you have to proactively fight that. But that's also why it's great to hear, from people like you who are actually, generalists, and yet at the same time are doing really, really well. So that's fascinating. Good. So let's dive a little bit into the kind of work that you're doing these days at Proton. And I think the big story there is this Lumo AI offering that you have since quite some time. So, maybe I put it in an almost sort of standard business school type of way, is like, okay, what is Lumo and what problem are you actually trying to solve with this product?
Mm-hmm. So Lumo is, basically our USP is about being your private alternative, your private ChatGPT. That would be the tagline if we were allowed to use ChatGPT in sort of marketing materials. But basically, people are putting up their lives. Before, people are using things like Google search. They're still using that too. everything they type is being used to create profiles of them, to understand what they want, what are they interested in, what products are they going to buy, what are they going to do in the future, like their demographics, everything that can be used for some sort of marketing side is being used like daily for the last 20, 30 years, right? Just to build these hyper specific profiles on users. And well, ChatGPT and the other tools are no different from that. Their core business is about generating revenue, of course. They're spending a lot of money and they're losing a lot of money. So they're going to have to start making that up pretty soon. So at the start, they've been sort of more concerned about getting your data for training, because more data equals better models. And you can only see, I remember there's like an interview from a couple of years ago, or maybe it was like last year actually, by one person that worked at OpenAI. And they basically said, no matter which architecture they use, no matter what experiments they use, the only thing that really makes a difference is like getting data. And that will make your model better. So now people are really understanding that they're giving up all their data on a daily basis now to these tools instead of necessarily to the classical big tech, which is like Google and Facebook and so on. And we saw this like last year, well, even before that, I would say, because we of course started working on Scribe before we released it, but we already saw the concerning sort of trend where advertising was sort of creeping in as a revenue stream. We already knew that people were giving up a lot of sensitive information, especially businesses. People were basically using ChatGPT to proofread their emails, for example, and then pasting them back into Proton Mail and then sending them. So what's the point in using Proton Mail if you cared about privacy, if you've just pasted everything into ChatGPT? So that's why we focused on Scribe, right, as a starting point. But you can see that, since that point, since last year, there have been so many things that have come out, which they're kind of obvious. So it's not as if we're predicting the future, because they're just playbooks of the past. But ChatGPT and now going for shopping, for example. So like, traditional shopping platforms know what you browse and you buy, but AI assistants know why you're doing it. So you're having these unfiltered conversations about your problems or insecurities or your health or family, and then when that context is going into commercial environments, the system knows when you're going to be vulnerable to those persuasions, right, and to the tricks that they'll use to be able to get you to buy something. So yeah, our goal is to protect users and their privacy. AI is the emerging and quite vast threat space, and Lumo is our play into that. And we have some way to go in getting to where we want all the feature parity that we have with other systems. But this is a start. People have been engaging with it. People like it. I think they like the cat quite a bit. I think the quality of the results are quite good. And we're running it efficiently. We're not throwing a bunch of money at it, paying for lots and lots of GPUs to be able to run one big model. We're basically going the route of smaller models, a bit more specific to certain tasks. One that's maybe good for math, one that's good for summarization, one that's good for general summaries and general chats, one that's good for reasoning or not, and coding as well, of course. And by doing that, we're much more efficient. We keep our resource usage down, which people really care about a lot. One of the things that you see in the discussions is that not only are people concerned about the privacy implications of AI models, but also the resources taken to run them. And the privacy aspects go not only in the side of what happens when it's deployed and consuming your information or your training, or retraining the model, but also what happened before, like all the scraping of data that people did to be able to get to that model, which is now quite powerful. So the ethical concerns around that, and people refuse to use AI because they feel very strongly about that. And yeah, we're trying to offer people an alternative which balances some models which are more powerful but are less open, and some ones which are very open, like Almo 2 was the one that we focus on because that was out before Apertus, for example. But Almo 2 is basically aligned very much with the types of with the thoughts that Apertus have, what went into developing Apertus. They opened up all their data. They have all their data sets open. They have open weights. They have open code, and I think it's been developed the right way. But
yeah. So yeah, I would love to double click on that a bit later. But first, maybe when you say, okay, we're trying to protect the privacy of the users who want to use AI, and that's obviously something that a lot of people want to do, which sounds completely reasonable to me. So what does that mean concretely, though? How can you actually guarantee that? I mean, not in the sort of mathematical sense, like demonstrate your guarantees, but more in a practical way. What does that mean? Building an AI service that is respectful of privacy these days.
the first part of it is that, of course, doing fully end-to-end encrypted AI inference it's possible, but not practically possible. So it's possible from a theoretical standpoint with homomorphic encryption, but you may be waiting days to get like a couple of paragraphs out of the system. So I think that part is a great research area, but it's not really tractable at this point in time. For now, what we're focusing on is more what can we practically do to get to something which is as private as possible. So the first part of that is that whenever you're sending a request with Lumo, for example, you type your query into the input box or your message, and at the point that you click on send, we encrypt it with the public key of the server, the GPU server. It passes that information through our services. We don't log anything on what's being sent. It gets sent to our GPUs. The GPUs are the only ones that have got the private key to decrypt your message. We run the inference, send it back, and then once it's complete, all traces of that original prompt are gone. Right, so it's completely ephemeral from that point of view. Once it goes back onto the client, it's streamed back through. At that point, if you're logged in, you can decide to persist it. Right, so you keep it. So you want to, when you open up your mobile phone, that you also have Lumo and the same conversation there that you can carry on. So what we do at that point is encrypt it with the user's keys. So we don't have any access to those either because, well, basically Proton doesn't even have access to the key because it's also being encrypted with the user's password. So like we have no way to be able to decrypt this on our side, which is exactly the same as what happens for Proton Mail and Proton Drive and the rest of the product suite. So we synchronize that back to our servers. It's what we call zero access encryption. So we're not able to get access to it. Only the user is able to do that. And yeah, that's sort of the high level helicopter view of how we do privacy focused AI. And then no logging. We don't know which requests are coming where from the GPU server. We have sort of an anonymous request ID, which is sort of forwarding everything through, but it doesn't tie it back to the user.
Mm-hmm. And do you think, like, there's a certain line of thinking that says, well, look, one day, in any case, everything will be running locally when the models are smart enough, or the computer's strong enough, the chips in the phones and so on. What's your thinking there? I mean, personally, I'm not sure I'm buying this. I'm sure there will be great use cases, and presumably there's already quite a bit of AI running locally, but presumably just, I mean, practically speaking, nevertheless, a lot of services run elsewhere, and the AI needs to be where that service runs. In addition, I assume many of the truly powerful models will nevertheless remain server-based models. So what's your thinking there? I mean, one way also to go at to this question is what are alternatives, not per se to Lumo, because I think it's a great service, but like what are the things also that others are doing? Like, Apple, of course, always comes up as the, a very privacy respecting company. At least that's the pitch. Is there not enough that's happening already? And do you think they could push further?
Yeah, I mean, they can push. There's like, say, encrypted enclaves or the secure enclaves. These are one way that people tend to, but it's more for CPUs rather than GPUs. But there is some research in this area of how to do it better. That works. I mean, the Apple Private Compute Cloud, is like PCC or whatever I think they called it. That is also very strong research. They poured a lot of money into doing that. They also use like oblivious HTTP, for example, so that they can't tie a request back to the user. But that's kind of required because they do have local models that can run. Also highly specific for certain tasks, which is the kind of the route that we wanted to go to. So they have a model for, I think their general approach is maybe they have a base model and then they basically plug on adapters on the end of each one, so it's quicker. So you have a model for summarization or something else for translation or something for something else. So you basically have different models that can do certain tasks, but they can run very quickly on the device. So sort of like a mixture of experts, but less integrated into the architecture, more of being just like an infrastructure of models rather than being into the architecture of the model itself. So for how things are going to evolve in the future, I do think that local is going to become more prominent, but I do think that it will always be the case that the most powerful models are still the ones that run on these big servers, right? It's not going to be possible it's not really scalable either, right? From an ecological point of view, for someone to run like a H100, even one H100 in their house, it takes up a lot of energy. Running 2 or 3, then you need like basically water cooling. So now everyone needs water cooling also in their houses for doing this. There is an efficiency of scale by having these resources sort of centralized. Also for maintenance purposes, and when it goes down, what do? You have to go and buy another card. Whereas if you're not in a data center, they can switch it out, or they've got people that are dedicated to maintain this. So yeah, I think that there will be an evolution not only in the types of models that we run, but also the architectures that run them. And also, LLMs are, I would still say that they're the infancy of the development cycle. We don't exactly know what it's going to be like in the future. Like Jan LeCun's type of JAPA approach, I think, has pretty good validity. It's how we humans tend to learn with real world interactions or real world objects, and seeing and hearing and so on is a big part of how we learn. So only focusing on text, probably not really the way forward. So I think that the architectures that we're going to have in the future are going to be very different. We don't know how they're going to run. Are they going to run on classical computes, or is it going to be something which is more like the sort of the brain computers, neuromorphic computing type of approaches? And that's not something that people are going to have on their homes, right? They're not going to be general compute machines. They're going to be very specific compute machines. So, one example of a company which is doing, I think you had them on your podcast recently, right? This Cerebrus.
Yeah, it was actually the first podcast with JP Fricker, the
Yeah,
co-founder and CTO.
this is super cool. Fundamentally, what they're doing is simple from the point of view of like, bring your compute and everything close together, make it run fast. But what they achieve from doing that is incredible, right? So you're getting 2,500 tokens per second versus like 60 tokens or 70 tokens per second on a H100. This is quite incredible. But they're hyper specific for this type of task. So running something with that type of throughput is not going to be something which is ever particularly general. It's the same as using CSCS, for having your high performance computing. It takes a certain level of skill to be able to even run stuff on those infrastructures, and it takes a lot of skill to be able to run it, to be able to cool it, to be able to get the electricity supply in, to be able to set it up, and so on. So I think that there will always be a case for having more cloud deployments, and we have to go some way to making sure that that's going to be more secure also over time. But also, I think with the development of things like homomorphic computing, so there's one company which I quite like in Paris called Zama. Zama are really kind of leading the way, I would say. Maybe there are companies too, so I apologize to them, but at least to my knowledge, they're the ones which are really pushing along with fully homomorphic computing within the LLM space, and they're progressing year on year, right? So one part of this is making the software better, but also they're also making like the hardware side of it too. So making the hardware function well with homomorphic encryption is going to be key. So yeah, as it stands, if we were to sit here and say that nothing else changes, but the infrastructure which deploys it has to change, yes, having Apple's type of private compute, having secure enclaves and so on are important. But if we look 5 years down the line, will the things that we're running now, will they be what we're running in 5 years? Probably not. Use cases will change, integration will change, deployments will change. People will be running it more. Maybe they're going to be running it with on their glasses. So you have it more on your mobile phone, but it's not going to be powerful enough to be able to do all the real world stuff that you need for proper augmented reality. Is it going to be something which is in your earbud that's talking to you all the time, for example? We don't know, and there's lots of cool developments that will come out of this, but also, with everything else, Proton's purpose is not necessarily just to develop the products with a privacy mindset, but also to make people really consider it as part of their business model as well, right? So we sort of show people that privacy is a business. I mean, you don't have to just sell data to be able to be a good company, but you can do this in a way which also respects people's privacy and not just treat them as being the product. So I think also that part is going to change. Well, hopefully it's going to change, and people see that's also a viable route. So they'll build in privacy from the start rather than just having it as a marketing tagline.
Mm-hmm. Yeah, that would be great. At the moment, we're seeing a bit sort of a tendency to go towards the other side. I mean, if we take, for example, the recent push in AI browsers, that seems to be. I mean, I'm fairly exploratory when it comes to new AI products, but here even I go, I'm not comfortable just handing over pretty much the entire interaction with the web that I have to one company. And it seems like, there's been some discussion about it, but as I wrote when this was launched, this sounds like a privacy nightmare, and it sounds like it's going to be super successful. So is that something that's on your guys' roadmap too, that you eventually say, hey, maybe we actually need to develop a browser because everybody is pushing towards that AI browser, and if we lose the game there, then it's basically game over?
I don't think so. I mean, I think browser, I'm not able to say that we're going to develop a browser at this point in time, I would say. But as it stands, it kind of would make sense from a strategic point of view. I think the way that OpenAI have implemented it is kind of looks rushed, probably. It doesn't really function better than having a sidebar extension in Chrome. I would say it's basically the same level of integration. But, the stuff that we talk about with shopping in ChatGPT, basically, the shopping thing came from Stripe. There was a partnership with Stripe and Etsy and ChatGPT, I think, or OpenAI, to basically provide this sort of information, provide product recommendations directly within your conversations. The same problem exists within the browser, but it's probably even worse, right? So the amount of surveillance that comes from having a browser, basically every interaction that you're making on the web is now being tracked, right? So before you're entering stuff into ChatGPT and it still didn't have full knowledge of all the rest of the stuff you were doing.
Exactly.
It understands what you're worried about, what you're interested in, what you're talking about with ChatGPT.
Where you're putting your attention, right?
Yeah, all your attention is basically theirs, right? It's ironic that attention is all you need. It was the paper that sort of kicked all it off, but that's basically attention is all they want at this point. Surveillance is basically unavoidable once you start having browsers like this. People have to remember that companies like ChatGPT are around not necessarily to make your life better. It's to make them money. So whenever they're making these types of products, it's basically because they need to make money, right? That's going to be advertising or shopping or both. But once you start having giving all your information to these types of companies, the amount of surveillance capitalism that can be carried out is quite amazing. And it's the same for basically OS level type stuff, right? And you could also argue that Android, like Google and iOS, could also have perfectly good profiles of every single user because they basically have their operating system. So everything you do, from the apps that you use to the stuff that you do on them, theoretically could go back to them as well. Whether it does or not is something else. But for ChatGPT, we know that that's what they're doing. We know that they're collecting everything that people are doing, the behavioral profiles, what they're interested in, how they're going to sell them products, what they're going to advertise. And it's going to be, well, if it's not checked, I would say it's quite a big threat as a monopoly, right? Because you would have basically all the information that you'd ever need to be able to build a hyper profiled or hyper good profiles of customers.
Yeah. Yeah, and then in addition, right, there's this agentic development, which sounds super interesting from different angles and also very useful. It's like, oh yeah, of course, right. It would be nice if I had some agent running in the background that does this for me and that for me and checks my calendar and makes sure I'm up to date with my prescriptions or whatever, right? Makes me suggestions for travel and so on. But I mean, there also the challenge will be whom are you handing over just tons of amounts of extremely sensible information and access data, right? Because these things obviously to be super useful, they will need to have access to certain things. That's I guess another frontier, right? That's opening up.
Yeah, I mean, so far people have FOMO, the fear of missing out, and they're plugging in everything to everything. Sort of similar to what happened with internet connected webcams and everything else that came before, and then they realized that people are just watching them in their households because the cameras have basically no security. So I think within probably hours of Atlas being released, they basically already found ways to hijack it. Agentic approaches are interesting because so far I also deal in anti-abuse, of course, and account security type stuff. And one of the big issues that we have is always things like info stealers on people's machines, or supply chain attacks. Some people are just installing npm packages for some development and then getting hijacked, and suddenly all the data is going somewhere else. So agents, people are just plugging it in. You imagine it happens because, well, one way the marketing of the products has made it seem that these products are actually intelligent, even if we always say that they're artificially intelligent, that they're reasoning models, but they're really not really reasoning. I mean, there's different variations of reasoning, but people are not really sure about maybe what the full definition is. But anyway, let's say it's not exactly what the marketing says. So then when people go on they hook up their agent to start having access to their bank details, for example, or to submit tax returns for them, or to book a flight or anything else, they have there's an error rate, right? So if you're going to have say the best coding models and some of the benchmarks is it 40% score or something like that. I think even Claude 4.5 Sonnet, which is arguably one of the best models, the accuracy rate is the score is like 40.5% or something like this, which isn't great as a score, but it's still better than most humans. So it's already pretty good. But the problem is if you stick these types of models or these types of agents into real life, and they have even an 80% accuracy, and they end up booking the wrong flight, or like paying the wrong person, or moving the wrong amount of money. I mean, it won't take very long for the AI winter to come along, because people basically say, well, this just cost the economy billions. Let's turn it all off, right? So I think people have to get away from the hyperbole, and also from being too keen to adopt things too quickly, and just to take a step back and say, well, actually, maybe we just wait a little bit. We see how it plays out. We make sure these companies are actually trustworthy. These agents are trustworthy. We look at the accuracy of them. They have benchmarks. They have test environments. Instead of just pushing something out into the open and seeing what happens. I think there's a whole security problem aside from the privacy implications, but security and privacy at this point are both pivotal concerns.
Yeah. It's interesting there. I mean, as you know, having worked at Facebook, but it's common knowledge, right, that the original motto was move fast and break things. And now that it's almost like that's how users start to behave, right? Because they, as you say, right, they have FOMO. But in addition, of course, some of that stuff looks genuinely useful in a new way. And so you do want to sort of try these things out and adopt them quickly, but only later do you realize, wait, did I just give that tool access to, you know, all of this information, and did I just share like my most personal health issues and, you know, whatever? And of course at that point, yeah, you have. I mean, it's almost too late. It's a bit that part is really, yeah, quite fascinating, and that's why I think it's so important that people are also aware of the kind of alternatives like what you are building.
Yeah, we don't support agentic flows yet, like at least those types of flows, but I think that's definitely, the API is something that people have been asking for a bit, so that's something that we're going to look at. But even so, I mean, like connecting, there's always this problem, typical systems of multi-tenancy, and you see multi-tenancy quickly dissipate when people start looking at things like MCP, right? So like MCP is, I mean, I don't know, it's the first time I've ever seen something that was called a protocol become so sexy as a thing. It was kind of
Yeah, so
encouraging.
fast.
Yeah, as someone that worked on standards for quite some time, to see a standard become like a major news article about something so crazy is kind of hilarious. But basically, people are they're adding these layers inside. Not everyone is super careful about the access that's been given to each of these agents. I mean, we put in security layers all the time for people. We for insider threat, for example, we look for people that might be, say, at Facebook or whatever, people looking at lots of documents that are not relevant to the work at all. But suddenly, if you give an agent that facility on your orders, let's say, to go off and search stuff, of course, the first thing it's going to do is start indexing everything, because that's the way that it's going to be able to find things quickly. So it's going to be pulling stuff that it shouldn't be doing. It's going to be doing things it shouldn't be doing. And
Yeah.
in a company, you have to have like the right safeguards in place. You have to be ready for this type of integration rather than just plugging it in and hoping for the best. And it's the same thing for whenever I worked as a data scientist, you had different companies that had different capabilities when it came to providing the data to get the work done, right? You had this data science boom, but then people said, okay, let's hire the data scientists, but then they didn't have the access to the data or the data quality or anything else or the compute to be able to do something useful or to deploy. And then when you go towards agentic AI, one of the cool things I think about agentic AI is that it has modernized some companies. So they have focused more on like AI first development. So AI is APIs as interfaces between departments or between systems. Whereas before, these systems were kind of more closed off. So for automation in general, even if you don't go down the agentic AI platform, even just for having basic automation capabilities, it's already a nice thing that people are starting to go into that space as a preparatory stage. But doing that and then skipping the sort of the more complicated part of ensuring there's adequate security safeguards in place, that you have adequate monitoring, that the data of your users that is ultimately within a company, for example, being used to feed these systems is protected, and that you know where it's going, right? So, once you start going into agentic systems, how do you know where your data processor is, or like which country it's going to be based in? In Switzerland, for example, if you deploy the system in a bank, the bank has to process the data within Switzerland typically. So if suddenly you've got an agent which you just hook up into your system, which sends your data off to a web server for some search, wherever, you basically violated probably a couple of laws at the same time. So there's a bunch of things on governance which I think they're being skipped over because it's easier just to go fast and ask questions after, probably. But yeah, I think that people should just take a step back, I think, and say, is it really going to be worth it to? I mean, I think a lot of stuff is really. I'm not saying a lot of stuff is very exciting for me. For example, it really enhances my work stream like massively. I was always what I would consider to be a fast engineer, but I'm much faster now with this thing to help me out. So you have to be able to leverage it correctly, but you also have to know how to use it properly. Use it properly, but also be respectful of the data that you have and even the code that you have. For example, if it's protected under IP, then make sure you just don't send it off to some random server just because it's going to make you 5% quicker.
Yeah. So, speaking of servers, so how do you handle that? You have your own, you rent them, especially the GPUs. Where are they based? How do you handle that question?
It's hybrid.
Mhm.
So we have some GPUs within our Proton infrastructure. That's more for what we do for internal workflows. So like, internal customer requests, for example, will go through our system so we can answer them. Basically, it's our internal, what we call Proton GPT. So it was actually one of the first, before Scribe, the internal project that I worked on was Proton GPT, and primarily it was there to be able to use all the knowledge that we already have from answering people's questions already, our knowledge base articles, our internal knowledge bases, and use that to answer questions, like specifically the ones that are coming kind of frequently, and help the customer support agents move faster. For Lumo, all of our servers are in, so we use servers in France, and yeah, basically we have across a couple of providers, so for redundancy purposes, because we have to make sure that we don't go down and we're able to scale up. So we have a couple of providers. All of them are hyper secure. We are the sole ones that have access to the machines. We have monitoring set up to make sure that no one else tries to access them and so on. So yeah, we have very strict security requirements on all these servers, very strong monitoring, and then also they're only accessible by us and from within Proton. So basically any request coming in can only be sent. You can only receive a request on these servers if it's coming from Proton servers with their keys.
Mm-hmm. And one interesting development, at least from a local perspective, is that there are no machines, or will be no more machines in Switzerland, if I understand that correctly. Right? That's a decision that's been talked about in the media recently.
Yeah, it's been talked about. I'm not sure of the change in this one. We do not have any GPUs at present in Switzerland. That's true. The machines are in France, and that's kind of where, well, one is cost, right, and also providers. We don't have a lot of providers in Switzerland that can offer the GPUs that we need. Price is another aspect of that, and the prices are high. So if we had to pay the prices that we would need to pay in Switzerland, we'd have to pay, the customers would also have to pay a lot more. But the vendors that we have, their privacy policies very much align with our needs, and they have all the security things that they need also as well. But for strategically going down the line, certain customers and so on may need only Swiss servers. In that case, we will need to deploy. We'll probably have to do that by ourselves internally. But that also depends. There's a lot of hypotheticals. There's also many things still to happen with the discussions with the Swiss government. And yeah, that hasn't finished yet, right? So there's a lot more to happen there. I hope that we can. I think the current Swiss laws on privacy are, of course, the reason that many businesses are based in Switzerland. Also, the fact that the banking sector is so strong was because of the banking secrecy, which is basically fed into the rest of the policies that are now affecting our digital lives as well. And yeah, I think getting rid of that is going to be a major mistake. But yeah, it's above my level of discussions. I know Andy is speaking a lot with the Swiss government on this, and I know that.
No, sure. Yep. No, and we'll follow that also with great interest, because indeed, right, that makes I'm not per se an expert in the privacy laws, but from at first glance, it seems to make very little sense. And I always appreciate sort of the Swiss way of dealing with things, and in any case, right, there's going to be tons of debate, as there should be, and hopefully in the end, right, we get something that's solid, even though it takes a little longer. But I'm often a bit puzzled at some of the decisions. I mean, we recently had this debate about copyright right laws, and there was a political motion to change the copyright laws, but it was written in such a way that it would have essentially completely rendered any sort of AI research impossible, even from the good guys, so to speak. And of course, nobody intended that, but it's sort of a technology comprehension question. So, I mean, that's not per se a criticism. It just also means that we on the technological side, right, have to do our work to explain to people and the decision makers, what's at stake. Seemingly something smart can have extremely negative consequences down the line. So going back to the model, so you're using these different models. And so what are your sort of go-to models these days? And also something, of course, that would interest me, given the proximity here to the Apertus model, is what do you think about that? What you would sort of wish to see there on the roadmap from a model development like that? If that could actually, if you ever think something like that could be useful or not, I'd just be curious there to get your thoughts.
So next month we'll launch. So we've currently got a set of models that we use. So one for the classification model is basically super light, like Nemo from Mistral. There's an NVIDIA model with Mistral or something. I think it's like 7 billion parameters. That one we basically use just to decide where to route requests. Then we have, say, coding models like Qwen Coder. We have the Mistral 3 model, which was being used at one point. We don't use it so much anymore now. It's been deprioritized. We have Almo 2. That's mostly there because we really believe in having the open model, especially before Apertus came along. It was one of the strongest contenders in that space. But yeah, we change the models as things come along. So as new things come along that are stronger than before, we'll just use them if they're compatible. At the moment, we're actually focused more on changing the part of our architecture to make it even faster. So yeah, some parts of it are not as fast as say what you get with ChatGPT, because we don't have millions of GPUs, whatever they have, hundreds of thousands of GPUs. So you can't have a slight bit of queuing. But there are some new developments like TensorRT, for example, which can serve the models, do inference much quicker. So we're looking at using these types of things, and at the same time, then we'll start investigating other models too. Another one is for image ingestion and image generation. We're looking at rolling those out in the next month or 4 to 6 weeks, we believe. And then for things like Apertus and models like Apertus, I think Apertus is great because it's I'm really an advocate of open models. My wife also works at CSCS, so I've been following this stuff for quite some time, in fact. Because I think it's really great, and I went and spoke with some of the team also in Lugano back in April. I think the difference now is like Apertus has been, the primary reason is to develop a base model, right? So you have a base model for that you can build upon for starting to do things like in the biological domain or in the physics domain and whatever scientific domain you want to do. So there would have to be, I think, just a little bit more on focusing on it as a general chat application, chat model. And also at the end, it comes down to the amount of data and the amount of parameters, right? We've seen before, like going from say 32 to 70 to say like 100 plus billion models, the difference in quality can be quite huge. But also the training or the post-training for the types of interactions you want to get out of the model, I think there probably needs to be a little bit more on that for Apertus, probably for the chat applications. That's more going to the specificity of a chat model. But as a base model, I think it's really great. I think it's important that we do this. It's important that the Swiss government and others also invest in creating these models, because we need to have viable open alternatives also in Europe, not just rely on models coming from China, for example.
Yeah.
Or the US. So there's also some initiatives from the EU now as well. I think I read a few days ago about the Dragon model, but I think it's like 7 billion parameters or 3 billion. I can't remember exactly which one. I think it's good that the space becomes more democratic. You have access to these things, and you can, we can pick up Apertus and start using it. For example, tomorrow, we could, if we wanted to, go off and take Apertus and actually make it work for our use case even better. So that's on par with our currently deployed models. But yeah, I've only ever good things to say about the project, because I think it's super important.
Yeah. I mean, I agree also on the research side. I mean, just even if you remove yourself completely from any product, you can make a strong argument that we should ultimately try to understand these things much better, because we kind of built this world almost organically. We have this powerful technology, but frankly, nobody truly understands how they work. And to be able to have a sort of sort of bench, almost like a lab space to take these things apart, you need something like Apertus, where really every step of the way, starting with the data, is truly transparent. But it does make me sort of think, okay, I mean, right, we are obviously discussing about, okay, what can we do in the future, the Apertus team, and then there's also, I mean, if you close to the Swiss, the SCSC, the Swiss Supercomputing Center, then you also know that, of course, these machines have been bought, or at least ordered many years ago when the demand wasn't quite as high. So that was good timing. Now it will be much more expensive, and indeed, if we think about in the future perhaps being able to build even more performant models, larger models, we would of course need more GPUs. And at the same time, that it's not clear, right, whether that sort of investment would come from the government. So it would also be interesting to at some point, reflect on ways that organizations that have aligned interests can actually get together. That doesn't only need to be from the academic side, also from industry that would be interested that there would be such strong models. But yeah, I mean, have you ever consider training your own model, or is that just something where you say, no, look, I mean, we're doing many things, and that's really just not on the cards, and it would anyways need way too many GPUs, and we use them rather for inference as we do now?
So our primary concern was, I think, getting the product out and seeing how people would be receptive to that and so on. Strategically, it doesn't make sense to be reliant on other people if it becomes such a core part of our product suite. And if AI continues growing the way it is, then you have to think further down the line if this is a core part of your thing, you don't rely on someone else to do it for you necessarily. You should be thinking about what to do in the future. So it's something we think about, but not something that we've done anything about yet. I think there's still a lot of stuff that we have to do before we even get to that point. Doesn't mean we have to do all those things and then do it. We can do it also in parallel. But what's clear at the minute is that, aside from the output that you get from Apertus, that you've got something tangible at the end which you can give to people. You're also creating an ecosystem where you're training people as well. So the skills that we're going to need in the next 5 to 10 years are being developed within Swiss universities that can actually help us develop these things. So if we need to do hiring in the future, we can hire. If we want to have partnerships with universities, we can do that because we have the capabilities now to do it. And then there's going to be a strategic question also on the governmental level. It's like, what do they want to do? If the rest of Europe, depends where Switzerland sees themselves, but it's always kind of like an island within Europe. But if the rest of Europe is investing a lot of money in this, and if you're concerned about sovereignty, then having a Swiss model makes sense, especially when you already have a really good starting point to build upon. I mean, basically the next step for Apertus, even if you have the compute, you have one of the biggest supercomputers in the world, you have the talent, and now the question is about the data. How do we get the data, which is still ethical, to be able to train better models? Because the better models, they will only come from having more data. And synthetic data, I'm not so sure. People have different opinions on synthetic data, but synthetic data, for me, it doesn't make a lot of sense if you're training your model on data that comes from the same distribution. It's not going to tell you anything particularly new, whereas I think getting, say, more text from more actual writing from actual humans, that's the stuff that makes the models better, right? That's why Reddit and Twitter or X, whatever, they're all closing up all their doors, because they know that that's all the power from Grok and ChatGPT and Claude comes from this data. It's not coming from they do have the talent, they do have the compute, but the driver is the data.
Yeah. Yeah, no, that's going to be a key question. I mean, I do think there's still quite a bit to be gotten. I know at the moment, of course, people have been looking a bit down on sort of algorithmic breakthroughs. I mean, not down, but sort of in the sense of the bitter lesson that in the end it just all comes down to throwing more compute at more data. But at the same time, My sense is that there are still somehow quite interesting unlocks available algorithmically. And also this sort of idea. I think I heard Karpati recently talk about this, of sort of just building actually relatively small models, but that are extremely capable. Not in terms of you ask them a question and they immediately know the right factual answer, but sort of there's just a cortex in the sense of being able to reason quite a bit. And what Giotto has been doing, that we had here on the podcast, where they seem to be winning this ARC AGI competition with a 200 million parameter model. So there's all of these pointers in this direction that seem to suggest there might be, perhaps it's very specific use cases, but there might be certain unlocks that that might be quite interesting from an algorithmic perspective as well. And that just seems a little bit more achievable, because how do you want to get more data ethically and legally? Is otherwise, right, seems to be almost an insurmountable challenge. Or I don't know if you have any ideas about this, where one could get this, right?
Well,
I mean, I guess it's possible. For example, in Switzerland, just take one example. In principle, I would argue anything that the Swiss tax-paid television and radio produces should, in principle, be, amenable to training, right? Sort of a win-win.
We also have huge libraries, right? That no one's even touching it. So that one of the interesting partnerships that happened recently was with Oxford University and OpenAI, and and you can probably guess why. It's not necessarily because Oxford is also a good name to have behind it as a initial partner for education purposes, but they also have one of the biggest libraries in the world. Right, the Bodleian has basically got a huge text of stuff which has never been indexed. Right, there's no digital copy of that, and for sure, I would imagine that the first thing they want to do is to start indexing this data, getting their OCR on it and getting it out, because it's basically stuff that they've never seen before. Right, and that type of text will help the models. I mean, but I think it also depends on the type of architecture that's going to. I mean, so far we're still creating memory machines, right? And the memory machines are requiring more memory. So the more memory that you have, the more ability to look and put attention on different things like that you can retrieve from your memory.
Yes.
The better the output that you can have. So, I mean, one way that people are augmenting this capability at the minute is using RAG type stuff, putting in the content as you get it. And that shows that you get much better results, but you still need to formulate it in the right way. I think the formulation, so far, a lot of this formulation comes from having big models that can already do it. Maybe one thing that they can probably do at some point is have smaller models that are still able to have relatively large context windows. But of the reinforcement learning part at the end, so the sort of the feedback approach is still generating content which is very cohesive and longer, for example. Because the thing that you see with especially when we're working with Scribe at the start, you're working with 7 billion parameter models, because that's basically what you can load locally. But as soon as you start comparing it even with a model not even double, the 12 billion parameter Nymo model that came afterwards, the quality difference was huge, right? It's not even it's not a small thing. It's really quite a huge difference. And you think going from 7 to 12, it's not big, but you're going from 7 billion to 12 billion. It's still pretty huge. So, and also the way that we build these models is still, I mean, I think everyone is kind of surprised, I guess, that they work so well. I mean, there's this story that I think I mentioned it before somewhere, but there's this story about ChatGPT. Basically, they released ChatGPT as ChatGPT because they didn't think it was a product, right? This is interesting. Let's get it out into the open. They don't even bother giving it a name.
It was called research preview, right?
Yeah, and they're like, oh well, cool. This is great. Now we just keep calling it ChatGPT, because they didn't think it was going to be as good as it was. Yeah. But it was so much better than anything that we were doing before that we were all kind of surprised. But I think we have to be careful that we don't get stuck, because what you see now is like a lot of research going into this one part of research, which is not, it's not even a huge part of it. Like there's so much stuff that's going on at the same time. But almost all the money has been diverted into this. And we have to be careful that we don't have tunnel vision, then lose 10 years of potentially groundbreaking research by focusing on the wrong part, right? And I think at the minute there was some luck, let's say, that this worked, and also perseverance, right? Because if you go through Karpathy's like tutorial and nano chat, whatever at the start, if you use that same type of architecture and use it on a compute that we have, or even like H100s, which are super expensive, the results are really underwhelming, right? You need to spend quite a bit of money training to get something that was going to be good. The nano chat one is pretty good, I would say, even after maybe 1 day or something of training, it's already doing some quite nice, giving quite nice results. But yeah, basically we're spending all of our time still thinking that this is the route, whereas perhaps something which is more flexible, something which is more aligned to how we actually store things, which is not necessarily as direct tokens, but as patterns of things that can then be related to tokens, or like how does the vision part fit in, or how does the speech affect the attention also that you give something. So I think these things are going to become more obvious as LLMs move more from still text words. Because even if we're doing stuff with images and video, we're still doing it as a prompting things like create a video with blah, or creating an image with blah. It's still you're going from text to image. Even the image models, basically you're still converting it into some sort of textual representation, which is going to feed in to the model to generate the text. But if you start combining all these words together, how does it start looking? And for sure, the current approach is not going to be the correct one, because to try and replicate the number of neurons in a human brain with what you have in terms of this, it would cost us we need a couple of nuclear power generators to be able to keep these models running. So maybe we just plug a brain. Maybe we start having a brain harvesting. So it seems like something from Black Mirror. I don't know if people know that TV show, but sort of dystopian reality where you start using even more biologically inspired interfaces, like maybe neuromorphic computing is the angle that people go for, and you start developing architectures which are more aligned with that type of, like also software architectures which are more aligned with that hardware thinking.
I think that would be super interesting, because it does strike me, and I guess it's not just me, but it does strike one as a bit bizarre, right? That the type of intelligence that we have today does not actually improve by interacting with it, which is pretty much the core of biological. I mean, not the core, but it's an extremely important thing. I mean, of course, there's pre-training, right, which is what evolution gives you a brain at day one. But then, right, from that moment on, any inference of the brain rewires the brain.
Yeah.
So this sort of test time learning, I think there were it was really early days and we're scratching the surface. I mean, I think you were coming back to the beginning where you said, and I fully concur, we're in very early days, right? I love this metaphor of calling it the MS-DOS time, right, of of AI. It's possibly even earlier than that, which is fascinating.
Yeah, it's exciting. I mean, I think the excitement is interesting. I think I've always been working in things which have, I think, become buzzwords. But now I started working in data science before it became a buzzword of data science, or bioinformatics before it was a buzzword of bioinformatics. But yeah, it's interesting now that you're really working in a field where basically everyone wants to work in it, but I think we just have to be careful about what people are going to work on. I think, not losing focus of what the ultimate vision should be was as actually having more intelligent systems that are more able to, more malleable, I should say. I mean, at the minute, we're kind of dealing with a black box, because no one really knows what's going on. There's research every week coming along about how Anthropic had one like last week about how these models interpret numbers, for example. The fact we don't even know that, it seems really fundamental as a building block, but we still don't know how that works. But it's also cool because, well, it's the whole point of science, right? You don't know how it works and you figure it out. And I think there's a lot of things that will come from figuring that out that will also feed into new architectures.
Yeah. Oh, that's super exciting. Good. I guess we are recording this on a Friday evening, so I also want to make sure I'm not taking too much of your time. TGIF for sure, but this was a great conversation. Thank you very much. And we have also your founder and CEO, right, Andy Yen, coming to AMLD in February as a keynote speaker. So very much looking forward to that and hearing directly also from him what sort of the roadmap is. But it looks like you're working on something super useful and important. And I, for one, I'm very glad that you're doing it. And it also sounds like it's an extremely satisfying time to be doing that from a technological point also.
Also tiring. It's a tiring time.
Also tiring, exactly. Which is why we're wrapping up now. Good, Eamonn, thanks so much. So I guess if people want to find more about you, I guess they can find you, I know, on LinkedIn. You're also blogging a bit on Proton. Are there any particular pointers, like for people who care about these types of things, where should they go?
That's a good question. I think most of my stuff goes onto the Proton blog. I do some writing sometimes on Medium. They're more high level blah type stuff, I think sometimes. But I'm very interested in the philosophical side of there's one thing on de-skilling, I think, and the future of work. I think it's really interesting from a philosophical point of view. It's like how we go through that. So yeah, I'm on Medium. I put stuff there, but if people don't want to pay for Medium, I can send them the article also. But yeah, LinkedIn is the best. I'm not on X, so
Yeah.
Blue Sky
Okay,
too.
yeah.
Also on Blue Sky.
Blue Sky, yeah. Good. Okay, good. Thanks so much for coming.
Thank you.